Good morning or afternoon, folks. Hope y'all are having a great day so far. Today's lesson it's lesson 4, making the moves. Okay. So in this lesson, our goal is going to be able to draw and describe translations, rotations, and reflections. So we've done some work drawing them, right? Just doing them, right? These translations, rotations, and reflections. The key difference today is that we want to be able to describe them as well, or identify them. Like, oh, this has happened. What's going on here? Okay, so focus on what you're going to need to describe these. Okay, like a translation. Okay, what direction and how far, right? Just an example. Okay, we'll get into more of that in the lesson. Okay, so let's get into it. All right, now for the starter, you might have seen, if you read ahead and checked it out, you'll see it says, here's a complete image. Your teacher will display the completed image a few seconds at a time. Your job is to complete the image on your copy. Okay, so check this out. Okay, what I'm going to do is I'm just going to scroll down and show you all this completed image for a few seconds. Now you could pause it, but don't. Don't do it. Okay, so I'm going to show it for a few seconds. You're going to try to draw it on your paper, in your book, on page 29. Okay, so let's give it a go, all right? That's it. I'll show it again for another 2 seconds. Okay, you ready? If not, pause it right now. Okay, now you ready? All right, cool. Ooh. Now, go ahead and pause the video. Try to draw it. Okay. Now, if you've unpaused the video at this point, there are a few things you notice when looking at the secondary, the image that I showed you. There was, in fact, a line of reflection, right? It looked like there was a reflection. I've just forgotten what it looked like. So I'm going to try to draw it, and we'll see if I got it right. Okay, so the line of reflection looked like it was going over one block, up one block, over one block, up one block, right? Over unit, up one unit. Okay, that's a slope of 1, but we'll talk about that later. Okay, so if I can draw, or if you can draw the line of reflection from memory, you can draw the actual reflection or the other shape, the completed image. Remember that the line between these 2 points, between B and where B prime should end up, is a line that is perpendicular to the line of reflection, right? That's this line here is perpendicular to the line of reflection there. Okay, great. So we've got B prime in the right place. It's 1 unit away, roughly. D is, D, look at that. That's in such a, why would they do that? That's so rude. Okay, so it's about 2.5 units away-ish. Okay, so we're going to put D prime right here. Okay, and then A, well, you can also do it this way. We know here that A is 1, 2, 3, 4, 5, 6 units away from B. So we just do that 1, 2, 3, 4, 5, 6 units away from B. That's A prime. We draw that. It makes a great triangle, and boom, we're set and done. You always have the completed image. Okay, if that's how you did it, great. If you did it a different way and you got the same image, way to go. Okay, perfect. All right, sweet. Now I keep saying image. The image is here. This is the shape after a transformation. Okay, not the image. That's the original. Okay, the image is the one I've circled. And we'll cover that a few more times. Okay, but let's move on. All right, so I do want to give y'all a chance to, I did get it right. Way to go. All right, so I want y'all to have a chance to go over the practice problems. So if you need to get onto Canvas and access those right now, or flip through your book to that back page, or to page, I'm trying to think what they start on. Page 26 is where lesson 3 practice problems start on. Go ahead and do that now. Pause the video while you're getting set up. When you're ready, hit play. Okay, so I'm assuming now you're ready. So let's go through them. Okay, so number 1 asks us to apply each transformation described to figure A. If you get stuck, try using tracing paper, okay, which we have, right? And of course you can take it home too, the tracing paper that is. All right, So the first question, A, was asking us to do a translation that takes P to P prime. This is fantastic. On an isometric grid, it's hard to say how many units to go in any direction, right? If we start here and we want to go 1 unit up, well, is 1 unit up here or is it here? I'm not sure. So luckily, the writers of this book understood that, so they made it a little easy for us. They want us to take P to P prime. Well, that's fantastic, because all we need to do is, we're not changing the shape at all, but we're keeping that point P and the rest of the points where they are in the shape and just moving it to P prime. That would be the correct answer for A. Okay, great. Now notice that none of the angle measures changed, none of the side lengths changed. It's exactly the same shape, just in a new spot. Okay, the orientation of the shape hasn't changed. It's still kind of sitting flat right there. Okay, so that's how we know that's a translation. We'll work on that one. All right, let's get back here. Okay, that's A. B is asking us to do a counterclockwise rotation of A using center P. And how far? Well, 60 degrees. Okay, if you ever reach a point where you think you don't have enough information to do a transformation, well, there's probably something you need to write about that in the question, right? If they didn't include 60 degrees there, we could not perform the transformation correctly. All right, so here it tells us we're using center P. Great, so our center P is just staying right there. Okay, and it also wants us to go 60 degrees counterclockwise. Counterclockwise being the opposite way the hand goes on a clock. So if you want to take a look at that clock, give it a go. I should really put that back here. That'd be really helpful. Oh, it'd be like reversed, because this whole camera is reversed or reflected. Okay, so it wants us to rotate this 60 degrees. Well, luckily, how do I know it's 60 degrees? Well, all these triangles are equilateral, right? So each of their angles are 60 degrees, every angle in them. So that means this triangle here, this part of the shape, between those two side lengths is 60 degrees. So if we were to take this purple line here and move it so that it's here at that next line, well, we would have a rotation of 60 degrees. So let's go ahead and give that a go. All right. So we're taking that top line, getting it to that next line, and that tells us it's 60 degrees. Okay, where this shape is compared to where it was is 60 degrees. And that center of rotation P is right there in the middle of that rotation. It's perfect. This is what you want. We'll label this shape A prime. Okay, because it's the image, it's the new shape after we have done our transformation. So that's called the image, right? So good work on that. Let's take it back. Actually, let's put it back there, because I think it wants us to do a reflection. Oh, actually, I'm prepared for this. So it wanted us to perform a reflection across line L. Well, we've got line L here. We just have to figure out how to reflect that across it. Okay, now with your desk partner, okay, I want you to discuss which of these answers do you think is correct. Which of these two, we'll call this diagram X, this diagram Y, which of these two pictures is the correct reflection? Pause the video, take a minute. If you're still here, if you're here now, I assume you've paused it, you've talked with your desk partner about it. So the correct one is actually Y. Why is that, you ask? Well, I'll tell you. Okay, so looking at X, right, it pretty much just looks like they've done a translation, right? They've just moved P to P prime. The shape is exactly the same. There's no reflection effect. The only shapes that are really the same with a reflection are equilateral triangles and squares and circles. Okay, are the only shapes where the reflection is going to be the same. Okay, maybe a rectangle, depending on where the line of reflection is. But everything else, we should, especially this shape, is going to be different on the reflection. Okay, so that's incorrect. y, as you can see here, and I think I showed it to y'all yesterday. Let me make this box bigger so y'all can see this. So check this out. Okay, so on x, if we tilt it so that the line's vertical, right, you can see that this is not a mirror. This box A over here is looking in the mirror and its reflection's like up above it, which would be terrifying. It'd make a good horror movie scene though. Now, if we do the same thing with y, we rotate it so that that line is vertical, we can tell now that that looks like a good reflection. Okay, where's my pen? There it is. Okay, so A is directly across the mirror from A prime, or the image, right? If we draw lines between the corresponding points, they end up being perpendicular to the line of reflection. Now, I'll show you that here, what I mean by that, okay? So, if I was to draw a line between corresponding points on A, let's say these 2 points, right? It intersects the line of reflection at a 90-degree angle. It does the same between P, and we'll call that P prime. It's a 90-degree angle. So it's a reflection. If we did it here between corresponding points, well, that's not 90 degrees. No way. Doesn't work. Okay? So y is what your reflection should look like. Okay? Good work. All right, let's go on to number 2. Okay? So number 2, we've got on the grid, draw a rotation of triangle ABC, a translation of triangle ABC, and a reflection of triangle ABC. The key thing for this lesson is this last bit where it says to describe clearly how each was done. So let's do a translation. Okay, translations are great because all we have to do is take our patty paper, grab the shape, and just move it somewhere. Okay, now if I was to, let's say I moved the shape here, right? So that means I've got C prime, B prime, and A prime here. Okay. Now, you could say you translated this shape so that B became B prime. What would be better in this case, be better, all right, would be to say it was translated 3 units left. Okay, and on your screen, yeah, that's going to be left too. Perfect. All right, now when we have a coordinate grid like this with squares on it, we can describe distance. So we should, because that's more descriptive than, say, being like, oh, from B to B prime, okay? Even though that also tells us exactly where to go. They're both great ways to do it. When I'm on a coordinate plane, I usually just say, oh, 3 units to the right, 3 units to the left, 42 units up, who knows, okay? All right, great. So that would be a good, clear description of a translation. Notice I have, it's a translation, how far did it move, and the direction in which it moved. Okay? Now, for the next one, okay, it's asking for a reflection. Now, for a reflection, that's going to give us a bit of a different shape. So let's actually do the rotation first. Okay? For the rotation, okay, we need to know that it's a rotation, so not a rotation. That's not right. So rotate this shape. Okay, great. We're rotating it. We can grab it. We can start rotating it. Oh, hang on. We need to know where it's rotating around. So I'm just going to say B. Rotate around point B. Okay, which direction? Well, I'll pick one. I'll just say clockwise. And let's say, how far do I want to go? I'll go about 90 degrees. Okay, so those are all the important parts of describing a rotation. What is it called? What's the center? Which direction? And what's the distance? So we kind of have 4 bits of information there. And if we want to do that correctly, well, rotating around B, 90 degrees means that A, well, if we went 90 degrees, that would put it about right here. So this is going to look a little bit funky when we do this, right? It's rotating around. Stop moving. Ugh. It's rotating till A gets to right about here, and I think that lines up all right. Perfect. Okay, so that would be a rotation around point B, clockwise 90 degrees. Okay, fantastic. And then the reflections are just so nice because they're so easy to describe. All you need is a line of reflection to describe a reflection, right? As I will demonstrate. Let's call this line, L. All right, great. The good old reliable line L. Okay, same thing we did on the last, on the last question, right? Lines between points and their images, not C prime. So the line between two corresponding points should be perpendicular to the line of reflection, intersecting at a 90-degree angle. Okay? And we'll do the same thing for A and C, and you should have a triangle that looks like this. And if we did do that reflection, we would just say reflect across line L. Ta-da! Fantastic. 4 points for everybody. Okay, let's go on to the next one. Question number 3. All right, so question number 3, draw the translated image for A, B, C, D, E so that vertex C moves to C prime. Now, vertex is a fancy way of saying a point or a corner on a shape. So E is a vertex, A, B, C, and D are all vertices. Okay, they're all a vertex of that point or of that shape. So all we need to do here is make sure C goes to C prime. Ta-da! If you did that, fantastic. You are crushing it as far as translations go, right? Now, the next one asked us to reflect. Okay, so this is a vertical line, which is great because we know all of these points are going to be directly across from each other, the same exact distance from the line of reflection as the original points are. Okay, so the image, or E prime, is going to be exactly the same distance from L as E is, and D prime is going to be the same distance from the line of reflection as D is. Okay, same with A, which is harder to figure out because it's just kind of far away. I'm eyeballing it. That looks good. That looks decent. This is going to be my best drawn. If I try to freehand this, it's a nightmare. You also don't want to see that. Okay. Oh, that looks really good, actually. I'm impressed with myself. Let's see if I'm still impressed. Holy moly, what on earth? Like, how did that even come up with that shape? It was ridiculous. All right, so there we have it. It doesn't look perfect, but actually, I'm not going to lie. That looks pretty good. Not to toot my own horn or anything, but dang, look at that shape. Whoo! All right, so great shape. Done deal. There's a good reflection. Okay, round of applause if you feel like you did a good job too. You can give yourself a pat on the back. I know I did. Okay, so that would be a reflection. Now, for the rotation, this one's interesting because we know it's a rotation. Let me get my highlighter out. It's a rotation of the pentagon ABCDE around point C. So C is not going to move. And it's going clockwise. So it's going the same direction as a clock by an angle of 150 degrees. Okay, so that's the tough part. Angle of 150 degrees. So how I do this, personally, okay, is I draw a line on the shape. Usually that line, well, always I can keep that line connected to the center of rotation. Because now I can figure out how far this new line DC is going to have to, or where that line is going to have to be. All right, so if CD is here, well, if I put CD there, that would be about how far of a rotation would that be? If you said 90 degrees, you're right. That would be about a 90-degree rotation. If we went this far, that would be about a 180-degree rotation because a 180-degree, well, a line is 180 degrees, right? So it's going to be between, because it's 150, it's going to be greater than 90, but less than 180. So I'm going to say, let's put it right about here. That looks nice. Doesn't that look nice? Looks great. So let's do that. Oh, man, I need to. All right, so let's rotate this thing. Oh my gosh, that is horrendous. Okay. Unfortunately, with the iPad, when you rotate stuff, it just looks really nasty. The rotations try to change up the size of everything. There we have it. So that would be a rotation roughly 150 degrees clockwise around point C of pentagon ABCDE. All right, now if yours isn't exactly like that, or if your drawing doesn't look exactly like this, that's okay. Don't worry about it. They didn't give us a coordinate plane, so we can't be really exact with it. Also, I'm not giving you all protractors right now, so we can't be perfectly precise. But if this angle between CD and CD prime is between 90 and 180, great. Okay, we just label that as 150 if we want to. Make ourselves feel good about it. Okay, so that's what your last question should look like there. Any questions? That's a silly thing to say. I can't answer your questions. I'm on a computer. I can't even hear you right now. But I'm sure you're saying some very nice things about my artwork. No, thank you. All right, so great work. Make sure that homework's submitted. If you want to take a second attempt on it today, great. Just make sure your first attempt's in. So because I update grades every Friday, right? So if your first attempt isn't in by Friday, you don't have a grade, and it's going to reflect in Skyward. It won't look good. So don't be doing that. All right, make sure you stay on top of that stuff. So let's take a look at 4.2. Okay, so this activity is, we're not using the graph in the book that's on page 30. Okay, we're actually going to be using a paper that the sub will have handed out, or you've collected at this point, which is this page right here. If you don't have this page in front of you, raise your hand or go ask the sub for this page. Okay, so what I want y'all to do is describe each transformation that's happening. Okay, so we need to include some important details on this in order to get these transformations described properly. Okay, for example, a translation, right, is we need to know which direction and how far, right? If I'm going to translate this pen from, that's a white pen, that doesn't look good. Okay, so you can see this one, from here to here, right? I'm not just going to say, put this here, right? That's so non-descriptive. Okay, but if I said translate this pen 5 spaces to the right, oh, sorry, that's your left. Okay, to the left, go 1, 2, 3, 4, 5. Assuming that we have a grid where my face is. Okay, awesome. So I want y'all to give that a go. Try it. If you don't get everything, like the detail perfect, that's okay. I want you to at least be able to name what kind of transformations these are. Okay, at least, at the very least. Okay, at the most, you're giving me all the details for them. Okay, perfect. Go ahead and pause this video. Try it with your desk partner. You'll be working and writing on this piece of paper. So please write on this piece of paper that is in front of you. Give it a go. Pause the video. And if you're here at this point, I'm assuming you have done the work and unpaused me because you want to see if you did it right or not, correctly or not. So for this one here, 1A, okay, this is a transformation, right? The shape is not changed at all. It's just in a different location. So what I would say for this one is translate A, B, C, because I need to tell you what I'm translating, right? Let's say to the right. Oh, and how far to the right? Well, it was 1, 2, 3, 4, 5, 6 units to the right. So translate A, B, C, 6 units to the right. Perfect. Look at that. It's a great description. I know how far, I know what I'm translating, even though that's kind of like obvious, and I know which direction I'm going in. If you did all that, perfect. If you got the number of units and the direction and didn't write to translate, that's okay. But get in the habit of telling me what kind of transformation this is, okay? Because communication's key, right? All right, so let's move on. Let's go on to 1B. Okay, so this, if you said this was a reflection, fantastic work. All right, now describing a reflection, we actually have to do a bit of drawing on this, okay? So for example, right, I could tell you, I don't want to do that yet actually. I can tell you that we're going to reflect triangle ABC. Okay, great. What am I reflecting this across? Well, you're reflecting it across a line. cross line, let's say line L again, for Lenny, right? We like Lenny. Lenny's a great name. Okay, now the only problem is here, I don't see line Lenny or line L. So what do I know? How do I know where this reflection is going to go? So make sure you're drawing the line of reflection. Okay, great way of figuring out where the line of reflection is to simply draw lines between corresponding points on your shape, right? Not only is your line of reflection going to intersect those lines at a 90-degree angle, so it's going to be perpendicular to them, but it's also going to be right in the middle. This is not a line of reflection right here. Where I put this line, no, it's not in the middle of those points at all. This, much better. Perfect line of reflection. Okay, if you did that, excellent. If you just told me it was a reflection, that's okay. I want you to start working on giving me more detail, right? So we're reflecting, what are we reflecting? Triangle ABC. Where to, or what are we reflecting it about? Across line L. Fantastic. All right, let's look at this one here. Oh, okay, so we've got another translation, right? I don't want dotted line for this. So we're translating this shape. Translate ABC. Great. And you could say translate ABC so that A goes to A prime, or B goes to B prime, or C goes to C prime. That would be fine. All right, you could also take a couple steps ahead and tell me exactly how far right and down it's going. On a coordinate plane, we have the ability to do that. We can't go diagonally. I don't know how far this distance is yet. We'll get to that much later. But I can tell you, right? Oh, we can go this far to the right. Ooh, maybe a little extra farther. And this far down, right? And I believe that is, what, 1, 2, 3, 4, 5, 6, 7. So 7 spaces right and 2 spaces down. So we're going to translate ABC 7 units right. That is a funky looking R. Can't have that. And 2 spaces down. 2 units down. Fantastic. Triangles are happy. Yes, just the reflection. What's that one called again? You're right, it's the image. Okay, the new shape after transformation is the image that will be on the quiz or the test or what we're having when we have it. Okay, so that's great. Let's go to 2B. All right, 2B, or I'm not going to make that joke. That's a bad joke. Okay, so here we've got something interesting. The shape is the same. Well, it's a different orientation, but it's the same shape, right? Unlike the reflection, which if we tried to line this shape up with the other one, it wouldn't line up. It couldn't. I mean, check this out, right? Even if I try to rotate the image, right? That can never fit up. I can never line up. It can make a really cool looking rocket ship or like a really funky looking diamond thing. That looks pretty neat. But it's never going to line up perfectly with the original image. And reflections have that. Like I said, unless it's a square or a circle, right? Or an equilateral triangle, depending on what the line of reflection is. So this is not a reflection. This is a rotation. We got a good bit to describe here. If you said it was a rotation, high five, way to go. That's awesome. Okay? Now, if you said we rotated, now here's the thing with a rotation. I could rotate this counterclockwise. I'm going to do that. Rotate ABC counterclockwise. All right, great. How far? Well, this is actually a 90-degree rotation. How do I know that? That's a great question. So something I'll do to kind of help me out, because these triangles are not on perfect grid lines. So we can't exactly say if it's 90 degrees or 180 degrees. But if I was to draw a box around this triangle, it's not going to snap. Let's do this. if I was to draw a box around this triangle, and I know that C is up here and the A ends up here, well, if I rotate that rectangle 90 degrees, right? Line it up here. I messed it up. I'm sorry. So it's what, 5 units? Should be 5 units by 3 units. 5 units by 3 units. 5 units by 3 units. Oh. So these grid squares are not perfect squares, but you can see that everything's in the same place. Okay? If we rotate this 90 degrees counterclockwise, we end up with everything in the same place. The squares on this grid are not perfect squares, which is why the dimensions are a little bit off. But this is a tool I use to kind of help figure out, okay, how far is this rotation? Well, this is a simple one. It's 90 degrees. I can see that. Okay? So it's a 90-degree rotation, and then you've got to figure out, well, where is it rotating around? Now, if you used your patty paper, you've probably figured out that the point of rotation was here. Okay? If you didn't, something you can do is figure out, well, C is the same distance from that point as C prime. B is also the same distance, right? We're going 1, 2, 3, 4, 5, 6, and then we're making a turn and going 7. Right? Same with this B. 1, 2, 3, 4, 5, 6, and we're making a turn 7. Which is the same distance away, right? Okay. So finding the point of rotation does get a little tricky. I use patty paper for it and have for a while. Okay, wherever I put my pencil and rotate it around that, that's going to be the center of rotation. And if they line up, then that's a great indicator that you have found the center of rotation. So to get back to the point here, we're rotating ABC counterclockwise 90 degrees around point P. Around point P. Okay, great. So you can either recycle these papers or you can hold on to them if you want to use them for notes, because this is good stuff to have, and you can use your notes on quizzes. So that's great. Not on tests though, right? We can use our notes and our workbooks on quizzes. So if you want to keep this for the quiz, it might be a good idea. Just saying. All right, so I don't want to go over this quite yet. We're going to kind of skip ahead and go to the lesson summary. If you would like to read the lesson summary on your own, that's fine. I do want to go over the glossary terms and give you all those definitions, but let's read through it first. If you'd like to read through it on your own, go ahead and do that now, and then just pause when you see me get here. If you want to read along with me, that's fine too, but I'm going to go ahead and read this. Okay? I'm going to silence that. All right. So the lesson summary starts on page 31 at the bottom of the page. Okay? And it says, a move or combination of moves is called a transformation. That's fantastic. We know that, right? That's a move or a combination of moves. When we do one or more moves in a row, we often call that a sequence of transformations. So think of what a sequence is, right? A sequence of events, a sequence of events, right? A sequence is multiple things, right? So a sequence of transformations is multiple transformations, right? To distinguish so for example, if you were to rotate a shape 90 degrees counterclockwise around point P and then translate it 7 units to the right, that would be a sequence. To distinguish the original figure from its image, again, image being the second figure, points in the image are sometimes labeled with the same letters as the original finger, but with this symbol. Okay, that is pronounced prime, right? So this is a prime. I think I talked about that a bit in yesterday's lesson. A translation can be described by 2 points. If a translation moves point A to point A prime, it moves the entire figure the same distance, and direction is the distance and direction from A to A prime. The distance and direction of a translation can be shown by an arrow. Cool, right? For example, here is a translation of quadrilateral that moves A to A prime, right? This also is a transformation that goes 4 units to the right and 1 unit down. Either way is a fair way to describe it. The key thing is with a translation that you need to include the distance and direction to describe. That's how you describe it. Now, rotation can be described by an angle and a center. The direction of the angle can be clockwise or counterclockwise. For example, a hexagon, A, B, C, D, E, F, is rotated 90 degrees counterclockwise using P. Okay, I want you to check out these descriptions, right? They tell you what's being rotated, how far, what direction, and what center. So make a note of that, right? The rotation is the direction of the rotation. The distance is the same as a translation, right? And then the center of rotation. So we've got the distance is 90 degrees, the direction is counterclockwise, the center is center P. All right. Now, a reflection can be described by a line of reflection or the mirror, right? When you look into a mirror, you see a reflection, right? When you check out your reflection in your phone or you're taking a selfie, right? Your phone is the reflection, okay? Check that out. Y'all's look crazy right now. Whew. Oh, wait, that's me. That's not y'all's. Oh, that's because I didn't do them. Oh, my gosh, I'm such a boomer. All right, so see? That's what y'all's look like right now. Or there it is. That's what y'all's are seeing. No, it's not. Huh, guess it's looking above. But when you take a selfie, it's like looking at a mirror. Okay, the mirror is the line of reflection. Each point is reflected directly across the line so that it is just as far from the mirror line, but is on the opposite side. We talked about that. Same exact distance from the line of reflection as the original point. So here, for example, pentagon AB, this is kind of hard to read. But for example, pentagon ABCDE is reflected across line M. Now, this is the great thing about reflections. All you need to know is what line are we reflecting across? That's all you need to know. Perfect. Now, for glossary terms, the sequence of transformations is just 2 or more transformations. In a row, right? So anything that requires you to make more than one move is a sequence of transformations. Now, with translations, right? So this is technically not a sequence. Okay, I know some people might say it is because we're going 4 to the right and 1 down. That's 2 moves, but it is 1 translation. Okay, we can also say that it's taking A to A prime, which would give us 1 translation. Okay, now a transformation, right, is exactly what it said up here. Okay, a move or a combination of moves. So when we move something, a move or combination of moves. This would be a good thing to have written down because it's, for notes. Okay. Now, if you still have time in class, if the bell's rung, then, get your stuff together. But if you still have time in class, I want y'all to give this a go. Okay. Name a transformation that takes figure A to figure B. And then name a transformation that takes figure B to figure C. Pause the video now, give that a go, play it again when you're done, okay? All right, so if you're here, I'm assuming you've finished. Now check this out, this is gonna be great. So what we could do here for our translation, we could label these points, not A, B, or C, but let's label this point X and this point Y, okay? So I could say, translate point X, or not point X, because we're translating the whole thing. Figure A, so that point X gets to point Y. Fantastic, right? Great. Okay. It also says name a transformation that takes figure B to figure C. Well, for this one, I'd probably want to, let's say here. Let's see this. Oh, this is cool. This is super neat. Watch this. So there's two different ways to do this, right? You could rotate it, I believe. Yeah, you could rotate this so that point would go here. It's a little more than 30 degrees. That almost looks like 90, but it's not quite 90. Okay, you could rotate it around this point here. If you did that, wow, good work. Okay, not bad. All right, tell me about it when I get back. I want to know. All right, you can also just reflect it across this line here. Calling that one line L. Good old Larry. Love that guy. All right, so, whoops. I can't write L's today. There you go, line Larry. All right, if we reflect it across, as you can see, right, these points, the lines between them are all intersecting that line of reflection perpendicularly. So that's great. Okay, so you could say for that, reflect figure B across line L, or Larry. Okay, that's fantastic. Now, for number 2, it asks us for a sequence of transformations that takes figure A to figure C. You want to see something crazy? Watch this. So a sequence of transformations is just more than one move, right? Anybody see that? No, good. Didn't think you would. So what we've written for number 1 is a sequence of transformations. We wrote a transformation that takes A to B, and then also a transformation that takes B to C. So if we just put those two together, that's a sequence of transformations right there. Ta-da! We did it! Okay, so fantastic. All right, now, if you have time, go ahead and get started on the practice problems for tonight. Those will be in the back of the book. What page is it? Oh, I can just find here. Not in the back of the book, sorry. Those practice problems start on page 34, or you can access them through Canvas. Okay? But good luck, good work, and thank you for joining Mr. Well. Don't forget to subscribe and... I'm kidding. Don't do that. Don't subscribe to this channel.